Hi guys, in this video we're talking about the third topic in P2, which is motion and forces. So we're going to go through some definitions to start with. So speed, what's the definition of speed? It's the distance covered each second or per unit time. So that's meters per second. Velocity is speed in a direction. So again, that's measured in meters per second. Acceleration is the rate of change of velocity measured in meters per second squared, because it's the rate of change of velocity, so it's how much velocity in meters per second changes every second. So meters divided by seconds is meters per second squared. Scalar quantities, can we remember what they are? They are quantities that have magnitude only. Okay, that might not make much sense yet if you can't quite remember, but vectors are different in that they have magnitude and direction. So for instance, speed is a scalar, because if you go 10 meters per second that way or 10 meters per second that way, it's still the same speed. Velocity is a vector in that if you go 10 meters per second that way, you could call that plus 10 meters per second, but if you go 10 meters per second that way, that would be minus 10 meters per second. It's got a direction, so it's a vector. Okay, calculations around these things. Speed equals distance divided by time. So remember, with the triangle, you cover up the one that you want to find out. So speed equals distance divided by time. Therefore, distance equals speed times time. Acceleration is the change in velocity. V is the final velocity, U is the initial velocity. So acceleration is the change in velocity divided by time. If you want to find out the time, it's the change in velocity divided by acceleration. You could be asked to find out each of those. This stuff is often represented on graphs. The first type is a distance time graph. So if you see a straight diagonal line on a distance time graph, that is a constant speed. That is, distance is going up as time goes up. If you see this, you've got a stationary object, because as time goes on, distance isn't changing. If we've got a really steep line, that's a really fast object. And if we've got an object going if we've got a line going in the other direction, going back down towards zero, we've got an object traveling the opposite direction. Same sort of line on a velocity time graph means slightly different things, in that if we've got a horizontal line here down at zero, that's a stationary object. This diagonal line this time, velocity is going up as time goes up, so we've got acceleration. Here, rather than meaning stationary as it does here, the velocity is constant as time goes on, so there we've got a steady speed. Really fast speed, gradually getting slower, and then we've got accelerating in the other direction. Okay, some more definitions. Force is a push, pull, or a twist measured in newtons. So force depends on, the size of the force needed depends on mass and acceleration. So from that we get the equation F equals m times a. So if you want it in a triangle, F equals m times a. Force equals mass times acceleration. Mass equals force divided by acceleration. You know how to use the triangle, that's fine. Balanced forces are when the force in one direction equals the force in the other, so there's no resultant force. Balanced forces occur when an object is moving at a constant velocity or when it's stationary. So unbalanced forces are where there is a resultant force, and that causes acceleration in the direction of the resultant force. So that could be an object speeding up, slowing down, or changing direction. And terminal velocity is the maximum velocity an object can move at. That's often talked about in the context of a skydiver or a falling object. So when we've got terminal velocity of a skydiver or a falling object, that means that the force accelerating the object due to gravity is balanced with the force of air resistance resisting it. Mass and weight come into this as well. What's the difference between mass and weight? Well, mass is essentially a measure of how much stuff there is in an object. So it's a measure, essentially, of the amount of atoms in an object, the amount of stuff, the amount of matter. That's measured in kilograms. The way I always think of this is mass, whether you're on Earth or on the moon, your mass would be exactly the same. Your weight, however, would change. And what's the difference between being on the Earth and being on the moon? The force of gravity is much less. So weight is the force acting on the mass due to gravity. One thing you might be asked to do with forces is to work out the resultant forces. So here we've got a free body diagram. So to work out the resultant, we consider the vertical components, up and down, and the horizontal components separately. So if we look at vertical first, we've got 10 up and 10 down. So if this is plus 10, and that's minus 10, plus 10 minus 10 equals 0 newtons vertically. And then we'll look at the horizontal components. If we call that minus 10 and that plus 20, we've got plus 20 minus 10, which equals 10 newtons to the right. So we've got a resultant force of 10 newtons acting to the right. So this object will accelerate to the right. Okay, final little bits on this. Gravitational field strength here on Earth is 10 newtons per kilogram on Earth. So that means every kilogram is pulled down with a force of 10 newtons. So if someone has a mass of, common misconception, commonly we say I weigh 80 kilograms, what we're talking about really is our mass. So if a person has a mass of 80 kilograms, they are being pulled down with 10 newtons for every kilogram, so they weigh 800 newtons here on Earth. On a smaller planet, they'd weigh less. On a more massive planet, they'd weigh more. Objects falling due to gravity. One question that's sometimes asked about this is if you drop a hammer and a feather on the moon at the same time, which hits the ground first? The common misconception is, the hammer will, because it's heavier. So this isn't true. If you look up on YouTube, hammer, feather, moon, you'll see, so hammer, feather, moon. It's an old grainy video, but it's worth a watch. You'll see that they actually fall at exactly the same rate. If you did that here, if you got a hammer and a feather now and you dropped it here on Earth, the feather would fall much more slowly. Why? Because of air resistance. So there's loads of air particles here on Earth, and each object has to push those out of the way to make its way to the ground. A hammer does that much more easily than a feather, so it falls faster here on Earth. But because the moon has no atmosphere, the hammer and the feather fall at exactly the same rate. Okay, I hope that's been useful. See you later.